For a third and final day of Volumes of Solids of Revolution, we're going to look at how to spin these regions around other lines, other vertical lines and horizontal lines. We've already looked at spinning around the x-axis and the y-axis. Now we'll look at y equals 2 or x equals negative 3 and things like that. For our first example, we're going to find the volume of the solid of revolution formed when the region bounded by f of x equals 2 minus x squared and g of x equals 1 is revolved around y equals 1. Maybe pause the video for a moment so you can copy that down. But the first thing we should do to try to solve this problem, of course, is draw a graph. We need to see what this region is going to look like. You're welcome to use the graphing calculator, although I feel like the graphing here by hand isn't anything super difficult. Plug in 0, you get 2. Plug in 1, you get 1. Negative 1, you get 1, and maybe that's good enough. I've got my horizontal line at y equals 1. I've got a parabola over here. That's the region I'm looking at. And I'm spinning this thing around the x-axis. Next, I'm going to go and I'm going to draw on my representative rectangle. Now, I've realized that when you guys have been doing the homework from the first two sections, you didn't always draw the graph, and you certainly didn't always draw on the representative rectangles. And I get it, because the radius was just, your function, or this function minus that, this function squared minus that function squared. Today, though, the representative rectangles are going to be really important. So I do need you to start getting in the habit of drawing in those representative rectangles. Remember that our representative rectangles always need to start on the line we're spinning around and go to our function. So here I'm going to start on the line y equals 1, and I'm going to go to my function, which is the parabola. By the way, I can't remember if I said this already or not, but hopefully you could look at this and realize if I'm spinning around y equals 1, and that's the region I'm spinning around y equals 1, there is no space between that region and the line we're spinning around. It is a disk method problem, so our volume is going to be pi times the integral from a to b of just our radius squared. And that representative rectangle is our radius. Now, before we go on, there are two things we're going to kind of get in our notes just as little bullet points. I need to figure out the height of this rectangle. And this rectangle's height is not 2 minus x squared. For example, if you're right here at x equals 0, what's the height of a rectangle at x equals 0? Well, it wouldn't be 2. If it was 2, that would be like if you were going from the x-axis up there. I think the height of your rectangle is just 1, or really 2 minus 1 over there. To find the height of this rectangle, we're actually going to go back to something we did with our area between two curves, start from section 6.1. And if I have a vertical rectangle, the height of that rectangle, the height of our radius of this cylinder, is just going to be the top function minus the bottom function. For vertical rectangles, the radius is going to be the top function minus the bottom function, which is what I'm going to go and do here. My top function is going to be my parabola. My bottom function is going to be that horizontal line. I'll do a subtraction problem. I'll do that in a moment. I want to get one more bullet point in here. If our rectangles are horizontal, like we saw when we dealt with functions of y and we were finding the area between two curves, I can't do a top minus bottom thing, but I can do a right minus left thing. For horizontal rectangles, the radius is the right function minus the left function. These two new ideas, combined with the bullet points we got in the notes from day 2, the ones that talked about if we're using vertical rectangles, we're using functions of x and we're integrating over x values, and if we're using horizontal rectangles, we're using functions of y and integrating over y values. These two ideas combined with that will take us through everything that we need to deal with for today. Going back to the specific problem I was looking at, my volume is going to be pi times the integral. My radius, the height of this representative rectangle over here, is the top function, my parabola, or f of x, minus the bottom function, my horizontal line, g of x, or 1. I'm going to say 2 minus x squared, that top function, minus 1, the bottom function, and I'm going to square that, and I'm going to integrate dx. Realize this is not a washer method subtraction sort of thing where I did the outer radius squared minus the inner radius squared. There's just one radius. This entire subtraction problem itself is my radius, which I'm then squaring. Next, I need to integrate over the x values for my region. Over here, our x-intercept would be at the square root of 2 and negative the square root of 2, but I don't care about that. I care about the x values for my region. My region starts at negative 1, 1 and goes to 1, 1, so I'm going to integrate from negative 1 to 1. At this point, you are welcome to simplify this thing if you want, or you don't have to bother, and you can go straight to the calculator. I might as well simplify it, because I can. 2 minus x squared minus 1 is really just 1 minus x squared. I'll square that radius. Go to the calculator, do your FN in stuff, although this one I feel like you certainly could multiply out and then integrate using our integration rules. But if you go to the calculator, maybe push pause so you can do this before I just give you the answer. And you should get 16 pi over 15. Next. Please, throughout this video, keep pausing the video. I'm going to move through this rather quickly because I don't think I need to do a lot of recording of me just sitting here. But pause the video, think through these problems, try to set things up, go to the calculator on your own, do the integration, and then unpause and kind of continue with things. Next, I want to deal with the region bound by y equals x squared, y equals 4, and I'm going to spin this region about the line y equals 5. The first thing you should do is go graph the region. So take a moment, again, pause the video, graph your region. This thing around y equals 5. So about that line over there. Hopefully you can look at this and realize there's space between the region I'm spinning and the axis I'm spinning it around, which is going to make this a washer method problem. And my volume is going to be pi times the integral from a to b of my outer radius squared minus the inner radius squared dx. Both radii must start on the line you're spinning around. So both of them are going to start on the line y equals 5. The outer radius needs to go to my furthest away part of my region. I have two choices. It could be the horizontal line, or it could be the parabola. I think the longer distance would be to the parabola. That's going to be the outer radius. My inner radius is going to go from y equals 5 to the closer part of my region, which is that horizontal line y equals 4. So that's my inner radius. And now let's see what we can do. Pi times the integral, I'll get the limits in a moment. My outer radius, this one over here. Well, the height of this rectangle is the top function minus the bottom function. On the top of the rectangle, I have that horizontal line y equals 5. On the bottom of the rectangle, I have the parabola y equals x squared. So my top minus bottom will be 5 minus x squared. I'm going to square that, and that's my outer radius. That 5 for the outer radius is my top. My x squared, that's the bottom. Minus. Well, the inner radius, the top of this rectangle is 5. The bottom of the rectangle is 4. They're just constant functions over there, so I'm going to say 5 minus 4 in parentheses squared dx. The 5, the top, the 4, the bottom. I'm going to integrate over the x values for my particular region here. My region goes from an x value of negative 2 to an x value of positive 2, so I'm going to integrate from negative 2 to positive 2. You're welcome to just go to the calculator with this. I suppose we might as well clean up 5 minus 4 and just say 1. By the way, what that's saying is your inner radius is always 1. No matter where this inner radius is placed, that height of the radius is always just going to be 1 over there because it's bound by two constant functions. The other one is changing because it's bound by the parabola on the bottom. Go to your calculator, type things in, and this should give you 832 pi over 15. Remember our rules we've been using. Ignore the pi when you go to the calculator. Type things in. You're going to get 832 over 15, and then tack the pi onto the answer. I have one more example that I want to show you, but there are 6 different parts to this, in an attempt to just show you as many different kind of variations on this stuff as possible. We are going to look at the region bound by y equals 2x squared, y equals 0, and x equals 2. And we're going to spin this about all sorts of different axes. That region, first of all, will be spun about the x-axis. Take a moment, sketch your region. X equals 2, bound by that. More or less, this is the region we're looking at, bound by that point, 2, 8. I'm spinning this thing about the x-axis. Take a moment, decide disk or washer. I hope you said disk. Which means my volume is pi times the integral from a to b of just the radius squared. The radii need to always start on the line we're spinning around and go to our function. So I'm going to start on the x-axis. Just one radius here is going to go to the parabola, and it's going to look like that. V is going to equal pi times the integral. Now the radius, I could do the top minus the bottom, which would be 2x squared minus 0. But we don't really need that minus 0 in there because it is just minus 0. So I can do like what we did on the first day and just say 2x squared squared dx. If you do want to see a top minus bottom thing, though, you're welcome to put in the 0 if that helps you now that everything else you've been dealing with has a top minus bottom. I'm going to integrate over my x value, so I'm going to go from 0 to 2, and that should be your problem. Go to the calculator and integrate this. That's going to give you 128 pi over 5. Next thing we're going to do, we're going to take the same region, and we're going to spin this around the line. Oops, I already said about in the beginning. Spun about, actually whatever, I'm going to write it again, about y equals 8. I realize this is going to be a pain, but it's going to make it a lot easier to get the formula correct if we redraw the graph every single time. So do take a moment and redraw that graph. Again, the representative rectangles are going to be a really big deal here, and it's going to just get too complicated if we have so many different representative rectangles on that original graph. So do your redrawing. Points 2, 8. I'm spinning around y equals 8. Going about that one. Decide for yourself, disk or washer. I hope you said washer. Which means my volume is pi times the integral from a to b of the outer radius squared minus the inner radius squared. Remember that our radii always need to start on the line we're spinning around. So both radii are going to start on y equals 8. My region over here is bound by the x-axis and the parabola. My furthest away part of the region is bound by that line, the x-axis. So I'm going to make my outer radius go from y equals 8 all the way down to the x-axis. My inner radius is going to go from y equals 8 down to the closer part of your region, which is the parabola, and it's going to look like this. And those are my two radii. My outer radius, actually you take a moment, pause the video, see if you can figure out the outer radius, and see if you can figure out the inner radius. Outer radius is the top, 8, minus the bottom, that's just y equals 0. I'm going to square that. The inner radius is the top, y equals 8, minus the bottom, which is the parabola, 2x squared. And I'll square that one. I'm still integrating from 0 to 2 over the x values for the region. Go to the calculator, type that in. You should get 296 pi over 15. Next, part C. Part C, we're going to spin this thing about the y-axis. Once again, sketch your region. And this time I'm going about the y-axis, so it's going to look like that. Decide, disk or washer. I hope you decided washer. Because if we're going about the y-axis, there's all this space in between your region and the line I'm spinning it around. V equals pi times the integral from a to b, outer radius squared, minus inner radius squared. Again, remember that the radii need to start on the line you're spinning around. So they're both going to start on the y-axis. Here's one. Here's the other. Outer radius is going to go to the furthest away part of your region. In this case, that's the vertical line x equals 2. That's my outer radius. My inner radius is going to go to the closer part of your region, which is the parabola. So it's going to look like that. Still intersecting at the point 2, 8. As for my outer radius, I can't do a top, actually for both the outer and the inner, I can't do a top minus bottom thing. I need to do a right minus a left thing. And I need to deal with functions of y. Well, I know that I have x equals 2 over there. I know that the y-axis is x equals 0. So my outer radius is just going to be the problem 2 minus 0. And I'm going to square that. The inner radius, I should do the right function minus the left function, and the right function is my parabola y equals 2x squared, but that's not okay. I can't call it y equals 2x squared because I need a function of y rather than a function of x. This is what we dealt with in the last video when we're spinning things around the y-axis. We need functions of y here. So take a moment, go through the algebra, and solve that thing for x. You should get x equals the square root of y over 2. Just the positive square root because I'm in quadrant 1 rather than in quadrant 2. I don't have to bother with the plus or minus thing. But once I have that, I can say that my inner radius is the right function. Don't call it y equals 2x squared. Call it x equals square root of y over 2 minus the left function, x equals 0, squared dy. Yeah, I guess since we're going around the y-axis, we don't really need the minus zeros, but you're welcome to include them if you want to see a right minus left thing. We'll see it's going to matter in the next example. Limits of integration. Because I have horizontal rectangles and I'm dealing with functions of y here, I need to integrate over the y values for my region. My lowest y value is 0, my highest y value is 8, so we're going to go from 0 to 8. At this point, go to the calculator, and I think it's probably, actually, no, we can clean this up a little bit to make it a little bit easier for the calculator because it doesn't really like dealing with square roots. I might as well clean this up and say 2 minus 0, that's 2, squared, that's just 4. And square root of y minus 2, y over 2 minus 0, that's just square root of y over 2. Square that thing, you're going to get y over 2, so that'll work. Remember that you can certainly type it in on the calculator just using x rather than using y. Doesn't matter what variable you call it on the calculator. And then go to the calculator. 16 pi for that one. Next, I'm going to spin that same region about x equals 2. Get that graph. About x equals 2, so I'm going to spin it about that line. Disk or washer? Oh, good. You're saying disk method. I'm sure you are. There is no space between the region I'm spinning around and that vertical line, which is why it's going to be a disk method problem. Volume is pi times the integral from a to b of just our radius squared. The radius needs to start on the line I'm spinning around, so it's going to start on x equals 2 and go to, well, our function that's bounding the region, so it's going to go to the parabola. It's going to look like that. That's my radius. Next thing I need to do is, well, figure out that radius. The right function is x equals 2. The left function, remember, because they're horizontal rectangles here, I'm not going to call my left function y equals 2x squared. I need a function of y rather than a function of x. So instead of calling it 2x squared, I'm going to call it x equals square root of y over 2. And that's my radius. What's on the right of your representative rectangle? The function x equals 2. What's on the left of your representative rectangle? The function x equals square root of y over 2. I'm still integrating over the y value, so you're going to go from 0 to 8. And I'm pretty sure that when you go to your calculator, it's going to give you a decimal that it won't be able to turn into a fraction. It's going to give you, okay, we're leaving the pi out of this, but it's going to give you something like 5.333333372 something or other. This is just because of how the calculator handles square roots. That's okay. It's really trying to tell us 5.3 repeating, which is 16/3, so I'm going to say 16 pi over 3. If you just want to multiply whatever you got by pi and just give an overall decimal, that's fine as well. We're going to follow the AP rules of accurate to 3 decimal places. 2 more variations on this. I'm going to spin this thing about the line y equals -3. Sketch your region. Here's my region, going about this line. Washer method because of all this space over here. Volume equals pi times the integral from a to b of the outer radius squared minus the inner radius squared. Decide if your rectangle should be vertical or horizontal. Hopefully you decided vertical. They're going to start on that line, y equals -3. Outer radius is going to go to the parabola. Inner radius is going to go to the x-axis. See if you can do the setup. Pause it and see what you can do. I realize this might look a little strange, but I'm really just following my rules of top minus bottom and all of that stuff. First of all, vertical rectangle, so I'm using y equals 2x squared rather than x equals square root of y over 2. I want functions of x here. The top of this rectangle, 2x squared, the parabola. The bottom is that line y equals -3, so top 2x squared minus -3 squared. You're welcome to make it plus, but I think it might be easier just to think about this if you leave it as a minus, because then it's truly a top minus bottom problem. Over here, the top of your inner radius is the x-axis, y equals 0. The bottom is that horizontal line, y equals -3, so 0 minus -3. Square that thing and go to the calculator, and I'm not sure what the answer, actually, let's see. I think the answer is going to be 288 pi over 5, maybe. We'll see. See what you get. If you get a different answer, send me an email. One more variation. Letter F. About x equals -1. Go sketch it. Sort of like that, spinning around that line. All that space means washer method. I'm spinning around a vertical line. My rectangles have to be perpendicular to it, so they're going to be horizontal rectangles. Outer radius is going to start on that line and go to the other vertical line that's bounding my region. And inner radius will start on my line x equals -1 and go to the closer part of my region over there. V equals pi times the integral. Actually, you see if you can do the setup. Should look like this. Outer radius, x equals 2, x equals -1, so 2 minus -1, I'll square it. Inner radius, the right is the parabola, but call it x equals square root of y over 2. The left is the line x equals -1, so square root of y over 2 minus -1 and square it. I'm going to integrate from 0 to 8 with a pi out front. Go to the calculator, 80 pi over 3.